Okay, so it says which of the following graphs represents the equation below? I'm going to grab your calculators, turn them on. You guys should be pretty familiar with how to do this. Now, I'm going to tell you something. While you guys are plugging that in your calculator, I'll do it in a second, but let me show you what Mr. Adams knows. Okay? And then this stuff is helpful. The more you know and understand about the graphing of these equations, the quicker you can pick up on a mistake. So, one thing I want you to be aware of is that if I were to graph, I'm going to call this h of x is equal to negative x squared. That looks like this. This negative sign just flips it about the x-axis. Now, what this term, this negative or this positive 4 does is it's going to take and rotate this is the parent function x squared, right? So imagine an x squared like this, but now it's going to rotate it and move it down here somewhere. So it's going to move it over. It's not exactly 4 units, but it's going to move that graph over here, and it'll sort of look like this. That's what the b term does, right? So this is written in standard form. My function right here, it's written in standard form. F of x is equal to ax squared plus bx plus c. Well, in this particular case, my a is 1. It's not written down, but it's there. B equals 4. And then what does c equal? Can somebody tell me? Well, there is no c. What's a number for nothing? What's a number that means nothing? 0, right? So c is always the y-intercept. Did you notice Mr. Adams graphed that thing right through here, the origin? So I basically, now, here's what I'm going to do. I don't need to, but I want to. So if you go to my website, we're going to graph this on Desmos, and then we'll graph it on the TI. I did the wrong calculator. I don't want that calculator. I want Desmos. So I just want to show you a couple of things. One, the negative x squared. And then I also want to show you x squared plus bx. Okay. And then let me zoom in on all this stuff down here. Whoops. So I'm gonna jump out because I didn't like the way the thing was set up. So I'm gonna say negative x squared. Whoops. Negative x squared, and then x squared plus bx. So all right. So watch what happens. This is x squared, the parent function x squared. The blue line is. As I change the value of b, see this b right there? As I change the value of b plus 1, see how that moves over? Now, because c equals 0, it's always going to cross through the origin. If I move it over again, it moves it down here. Now, notice it's not exactly moving at 2 units. It's moving at about 1 unit. So if I move this again to 3, the vertex is going to stay on this upside down parabola. So that's what Mr. Adams was trying to show you, okay? That's what I was trying to show you, all right? So this is the actual graph, and let's see what it looks like on our graphing calculator. So let me take a snapshot of that. That's important to know, because if I accidentally put a minus sign or a plus sign, or I make a mistake somewhere, then I'll catch it right away, because I have that knowledge in my head. Well, what should it look like? I don't have to know the exact values, but what should it look like? Okay? So this is h of x equals negative x. And this is x squared plus 4x. So lastly, real quick, what we're going to do is we're going to enter that into our graphing calculator, and you should get the same thing. So hit y equals, clear that out. Now, did anybody have any problems entering that in your calculators? So I'm going to hit x squared plus 4x. Hit graph. Oh boy, where is it? I don't know. So now I'm going to hit zoom. I'm going to go to standard fit. And now I have my graph. Okay, let me show that to you guys a little bit bigger. Here it is on the, oops, I zoomed in on it a little bit. So let me take a screenshot of that. So now, I think it's important to identify these key points, right? So it crosses through the origin here. I think this point looks like it's about 2 comma negative 4. I don't know if it is exactly. Or negative 2 comma 4. And this one looks like it's about 4 comma 0. And we know that this goes through the origin 0 comma 0. This is the y-intercept. That's because c equals 0. Now, one last thing. I am really over teaching this, but it's so important. Another way that you can find the vertex, if something is written in the standard form, if you want to find the vertex, then one thing you can do is that the x value of the vertex is equal to negative. Does anybody want to guess? We're going to use some math. It's negative b all over 2 times a. So if I put negative, what's b? What's the b value? 4. All over 2 times a, what's a? 1. Negative 4 over 2 is equal to negative 2. Right? See this? So I got this, x equals negative b over 2a. Now to get the 4, I'm just going to evaluate my function at negative 2, which is equal to negative 2 squared plus 4 times, this is negative 4, you guys. Come on, man. Negative 4 plus, plus 4 times negative 2. So what is that? Well, negative 2 squared is a positive 4. 4 times negative 2 is negative 8. That's negative 4. So that's how you get this term. So we were able to find it algebraically. And graphically. All right? Lastly, to find the zeros, I just have to factor this. But I won't do that. We've done enough for this one example problem. Are there any questions on this one?